Hi friends, we at the Higher Computer Academy are committed in providing quality education. We post videos regularly based on technology and career growth. Today, we will understand about joins in SQL. This video uses Oracle database, but the concept of joins is the same in all technologies, irrespective of any database or language. Before we proceed further, don't forget to subscribe and turn on the notifications to get updated on our latest videos. Joins can be performed on tables based on primary and foreign keys. So let's first understand these keys with the help of some sample tables from an organizational database. We have three tables, namely the department new, employee new, and salary new, containing the details of the departments, the employees, and their salaries respectively. We have limited the number of rows in each table for easier understanding. If you wish to recreate these tables in your instance of database, we have provided a link to the scripts in the description of this video. Every table in a relational database must have a primary key. This key consists of one or more columns in a table and is used to uniquely identify each row. In the employee new table, the employee number is the primary key as it uniquely identifies each employee or each row. Two employees might have the same names but can never have the same employee numbers and thus be differentiated based on the primary keys. Similarly, in the department new table, department number is the primary key, while in the salary new table, job ID is the primary key. A foreign key is a column or set of columns that refers to the primary key column in another table. It has the same value as the primary key in the reference table. Two tables are said to be in a relation based on the primary and foreign keys between the tables. Let's now understand the relationship between these two keys. In these two tables, department number is the primary key in department new table and it is the foreign key in the employee new table. The tables are related using these keys and can be joined to retrieve additional information from them. Similarly, salary new and employee new are related by job ID, where job ID is the primary key of salary new and is a foreign key in employee new table. What we need to always remember is a primary key cannot have null values, the column or columns must be unique, and there cannot be more than one primary key in a table. And a foreign key can accept null values, duplicate values are allowed, and a table can have more than one foreign key, referring to more than one primary key in various tables. Let's take a look at joins now. A join is used to combine columns from two or more tables based on values of the related columns. The related columns are typically the primary key column of the first table and foreign key column of the second table. The connection between the tables is established through the where clause. The query will look like this. The join condition is present in the where clause. You must prefix the column name with its table name when the same column name appears in more than one table. There are a few basic types of joins which can be used to display data from multiple tables. They are Equijoin, Cartesian join, outer join, and self-join. When two tables are joined together using the equality of values in one or more columns, they make an Equijoin. The Equijoin or inner join will display the matching rows in two tables. Consider the tables that we have mentioned earlier, employee new and department new. Suppose we need the department names to which the employees belong. We need to join these two tables based on department number. Why do we need a join? Because employee number, name, department number are present in the employee new table, while the department name is in the department new table. To get the department name, we need to join the two tables. Let's write a small query to list the employees' employee number, name, department number, and department name. Here, we have specified the table name for the column department number alone. If the table name is not specified, Oracle cannot decide from which table to pick department number and will give column ambiguously defined error. As you can see, the join condition is that both the department numbers should be equal for each row, and this will be the output of the join. Although the employee new table has 7 rows, this join query has displayed only 5 rows because an Equijoin displays only the matching or equal rows from both the tables, and in this case only 5 department numbers between the two tables match. We can see that there are no rows for department numbers 800 and 400 in the employee new table, and 2 rows in the employee new table have null values for department number. Similarly, multiple tables can be joined using the Equijoin. Suppose we need to display the employee number, employee name, department number, department name, job title, and salary of the employees. We need to join one more table, which is the salary new, from which the salary and job title will be fetched. The query will look like this. We can see three new variables E, D and S, which are aliases for tables employee new, department new and salary new respectively. It can be tedious to type the complete table names repeatedly, and aliases are used to reduce this. Using table aliases also speeds up the query. And the order by clause is used to sort the output by employee number. The output is shown here. This query has returned 5 rows because there are only 5 common records between these 3 tables. The next join is Cartesian join, and as the name suggests, each row of one table is joined with every row of another table. The where clause is not specified in the query, resulting in a Cartesian product. So let's try to join the tables employee new and salary new. We have the query for this join here. So the output of the join is here. The employee new table has 7 rows, salary new table has 4 rows, and this query will give you 7 by 4, 28 rows. If there are any values in one table that do not have corresponding values in the other, that row will not be selected in an Equijoin. Such rows can be forcefully selected by using the outer join symbol plus. The corresponding columns for that row will have nulls. Consider this requirement. We need to display the employees working in each department, and it must display the records even if no employees belong to that department. The query is shown here. And we can see the output. In this example, we have displayed the department number from both employee new and department new tables. The output of the SQL shows that there are 2 departments, namely department number 800 and 400, in which there are no employees. Outer join displays the matching rows as well as the non-matching rows, as in this example. A table can also join to itself. That is, each row in a table is combined with every other row of the same table. This self-join can be viewed as a join of 2 copies of the same table. The table is not actually copied, but the SQL performs the command as though it was. So here in the employee table, every employee has a manager, except for employee number 1, John, as he is the CEO. He is the manager of employee number 2, 4 and 7. Observe that a manager is also an employee. For example, employee number 2, Jim, is a manager of employee number 3, Doug. Similarly, employee number 4, Karen, is a manager of employee number 6, Sam. Let's now write a query to display each employee name and his manager details. Here, worker and manager are aliases of the same table, and the where clause shows the self-join. And here's the output of our query. Thanks for watching. Hope you found this video useful. Please subscribe and turn on the notifications to get updated as and when we upload new ones. Visit our website for more information.